This video, I'll show you how to create this animation using Manim. Manim is a Python library that lets you create animations using code. Python is a programming language, and the library is like a mod that you can add to it. It adds extra features. In this case, it lets you create animations. In two of my previous videos, I showed you how to install Manim on Windows and Mac, and in this video, I want to show you how to get started using Manim. So first things first, let's open VS Code. Here we'll want to create a new file. You can either click here or go up to File and New Text File, or Command N if you're really cool. Here it says that you can select a language, so I'm going to click here and we want Python. So I'll type in Python and click on it. I'm also closing this welcome screen. Next, I want to save this somewhere, so I'm clicking Command S or Control S on Windows, choosing my desktop, and I'll say that the name of this file is Shrek. Beautiful. If you followed the installation guide, you should already have the Manim side view, Pylance, and Python extensions installed into VS Code, so you'll be able to see the Manim side view icon over here. This one lets you preview animations that you create inside of VS Code without having to navigate through your file system. Also, I'll open the animation that we want to recreate inside of VLC so that it's easier for me to go frame by frame to make it easier to see what we're trying to copy. You can go one frame at a time in VLC by clicking E on the keyboard. But before we start animating, we first need to import Manim into Python. Remember, it's a library. So I'm going to say from Manim import Snowflake. What this does is it essentially imports the whole Manim library into our file. This white dot here means that this file hasn't yet been saved, so I'm going to click Command S to save it. Next, we'll want to create a scene. Essentially, each scene is a new video file, and you can create multiple scenes within one Python file. I'm also going to open my reference file and keep it over here so I don't make many mistakes. So to create a scene, you're going to say class, then the name of your scene, this can be whatever you want. I'm going to put XD123. And then inside of parentheses, you're going to say scene. And at the end, add a colon. After you click enter, VS Code will immediately indent this line for you. And Python is a programming language that really cares about indentation. So I don't want to delete this. I want to leave the indentation. It means that every single line of code that I write here will live under this class scene. So everything I write here will live under this. You can also collapse this and expand this if you want. To finish creating the scene, we're also going to say def construct and inside of parentheses self, and at the end add a colon. This just created a new scene with the name of XD123. And every single line of code in this scene has to live under def construct self. So don't delete the indentation. If I write something here, this text here is now living under class XD123 scene. I want everything to live under def construct self if I want it to be included in this scene. So don't forget this double indentation. Okay, and now we have an empty scene, like an empty canvas that we can use to create animations. So let's open the animation and see how it begins. First, there's this white square on the left. So let's start by creating a white square. In this case, this square is actually a rectangle with equal sides. So I'm going to say rectangle, and then inside of parentheses, I can choose between all of these parameters here. This is something that VS Code suggests. If you don't see these suggestions, you can click Shift Command Space or Shift Control Space on Windows. So here I can see that I can define the height of the rectangle. I'm going to say that height equals to something like 0.5. Also, when I add a comma, I can define some more parameters, and I can see here that there's height and there's also width. I said that this needs to be a square, so the height and the width need to be the same. So I'll say width equals 0.5. Now we have this rectangle here, but I also want to assign it to a variable. I'll say rect1 equals my rectangle. And this is something that I just made up. It's a variable. So now whenever I say rect1, Python is going to understand that I mean this rectangle. And now I have this rectangle, but I've just created it and I haven't put it on the screen. To put something on the screen in Manim, you use the self.play command. If you want to show an object appearing, moving, or disappearing on the screen, you always want to use the self.play command. Now inside of its parentheses, I'm going to say write and then rect1. It's going to use the right animation type to animate the rectangle on the screen. So now to run this code, I'm going to come here and say run Python file. It should open this terminal here, and then click on the Manim side view extension and select the name of my scene. This name here, XD123. Since I have only one scene, this is the only option. And once I click, the scene should be rendered. And as you can see, we have a rectangle. At the bottom here, I'm going to say self.wait and then put 3 inside of parentheses. This tells the animation to pause for 3 seconds. Now to re-render this, I can click Command S or Control S on Windows for save, and then it will re-render it. Now there's a 3-second pause after the rectangle appears on the screen. Beautiful. But in the animation that we want to recreate, this is fully white, and my rectangle is empty. So I'm going to come here inside of the rectangle parentheses, add a comma after width, and say fill_opacity equals 1. This sets the fill opacity, which is how visible the filling of the rectangle is, to 1, or 100%. If I said 0.25, that would mean 25%. I'll rerun this animation with Command S, and now the rectangle is fully white. Now notice here that there are actually 2 rectangles, and they're both white. So what I can do is just copy this one. By the way, inside of VS Code, if you come anywhere on the line that you want to copy and click Control or Command C and then Control or Command V, it will immediately copy and paste this line without you having to select it. So now we have the same thing, but I want this to be the second rectangle. So I'll change the variable so that these become separate things. Remember, we just created this rectangle, but we haven't put it on the screen because we didn't specify it anywhere inside of the self.play command. So copy this command and say let's play the second rectangle as well, and let's see what happens. There's the first one, and the second one overlaps the first one. So how do we move them? I'm going to make this a little smaller, and then I'll come after the first rectangle, say period, shift, left times 5. This will shift the rectangle 5 times to the left. Let's run this code and see what happens. So here's our first rectangle, and here is the second one. As you can see, this one is over to the left. If I said shift right 5 times, it should be over here. Yes, I'm going to revert this back to left. But what does this 5 mean? By default, the scene in Manim is made up of 14 by 8 squares. If you want, you can show the coordinate system like this. You create a variable, then say number plane, add coordinates, and then you play this on the screen, which will show the coordinate system. So this is how it looks like. And as you can see, this rectangle is shifted to the left by 1, 2, 3, 4, 5 squares. And since we didn't define another position for the second rectangle, it's just in the center. Now, there are a couple of different ways to move objects around in Manim. The first one is with the shift command. So you can say shift left by 5 and then shift up by 2. So it should end up here. Yes, so it shifted left by 5 and up by 2. But this is not super efficient. What we can also do is use another command. I'll use it for the second rectangle, which is period move_2, which lets us move things to specific coordinates immediately without playing with left, right, up, or down. So here we want to add curly brackets, and then we can define coordinates like this: x, y, and z. The z coordinate will always be 0 because we're working with a 2D environment, and you can simply pick whatever x and y values you want. So this is for the second square, and in the animation that we want to recreate, the second square starts off over there. So exactly the opposite as the first square, which means that the x coordinate will be 5 and the y coordinate will be 0 since the square is on the x-axis. So I'll say move to 5, 0, 0. And I'll also remove the coordinates so that they're no longer visible. And right now the first square is here and the second one is here. Now let's see what happens next. The second square moved from there to the first square. And that means we're going to write something inside of the self.play command since something happened on the screen. I'm going to add a few spaces here and say self.play. And this time we don't need to write out anything on the screen since both of these objects are already on the screen. We want to move the second rectangle to the first rectangle. So I'm going to say rect2, which is my second rectangle, dot animate dot next rect_2, this command puts something next to another object, and I have to define next to what. So I want the second rectangle to be next to the first rectangle, so I'll say rect1, and then I have to say on which side. So do I want it to be up? Do I want it to be left, down, or right? In this case, I want the rectangle to move to the right side of the first square. So I'll say right. So what this whole shebang will do is animate the second rectangle from its current position to end up next to the first rectangle on the right side of it. Let's see what we get. Perfect. Now again, if I change it from right to something like up, it will move over here. But I want it on the right side since this is the animation that we want to recreate. Now, just like next to, you can use the shift or the move to commands to animate something happening on the screen. For example, here we put both of these rectangles in their positions before they appeared on the screen. But another thing we could have done is made them appear in the center, and then instead of putting shift left 5 here, I could have said self.play right rectangle number 1 and then self.play rectangle number 1 .animate .shift left by 5 squares. So this puts the first rectangle in the center and then moves it to the left by 5 squares. So I just want to show you that you can also use the shift or the move to commands inside of self.play by also adding .animate next to the object that you want to animate. Okay, so this is what we have right now. Let's go back to our animation and see what happens next. So now these 2 squares transformed into 5 squares with different colors. So first we need to create these 5 squares and then transform these 2 white squares into these 5 squares. Now we could do this with a loop, but for the purposes of this tutorial, I'm just going to create 5 more rectangles. I'm going to name them R1, R2, R3, R4, and R5. By the way, in VS Code, if you hold Option or Alt, you can put multiple cursors and type at the same time. So if I type now, it types in all 5 lines, which is very useful if you want to type the same thing. So I want to type rectangle, then open parentheses, say height equals to 0.5 and width equals to 0.5 as well. Also, let's do fill_opacity equals to 1, just like we did with the first 2 rectangles. Now, instead of moving each of these rectangles next to each other like this, like we did with the first 2, we can put all of them in a group and then arrange all of the objects in that group nicely next to each other. It's a lot easier than doing this. So I will name the group group, and I'll say that it's equal to v group, which means vector group, and inside of the parentheses I can say what I want to put in the group. So I want to put all of the rectangles, R1, R2, R3, R4, and R5. Now all of these are in a group. I can still animate them individually, but if I want, I can animate the whole group, which will animate all the objects that are inside that group. But I also want to arrange all of them nicely in a straight line like this. So I'll come to a new line, say group.arrange and empty parentheses. This arranges every object in a group left to right and puts their collective center in the center of the frame. So everything will be nice and centered and arranged like this. But of course now nothing will show up on the screen because I didn't put this group or any of these rectangles inside of self.play. So I'll come here to the bottom, say self.play, right, and group. So it will use the right animation to create the rectangles on the screen. Let's see how it looks like. There's the first square, the second one, and then all 5 rectangles appear on the screen. But I want to transform these 2 rectangles into these 5 rectangles. So instead of right, I'll use replacement transform. And inside of parentheses, I have to say transform from what to what. So I want to transform from these 2 rectangles to these 5 rectangles. These 5 rectangles are in a group, so I can just say transform to the whole group, but these 2 are separate right now. So I can also put them in the group and then transform the first group of rectangles into another group. That way it counts this as one object and this as another object. And it will transform from this to this. So I'll come here above because I want to create the group before I transform it, and I'll name this group G2. Say it's equal to V group, and then inside of parentheses, rect1 and rect2. So these 2 rectangles. And then inside of self.play, I'll transform from G2 to group. So from this shape to this shape. Let's see how that looks like. Nice. So now we have this, but the rectangles here are colored in different colors. Now you can do this many different ways. For example, I could come to the rectangle and add a comma, say color equals red. And now if I play this, the first rectangle will be red. But this is quite tedious. So what you can also do is if you have objects in a group, you can color that whole group. So I'll say group because I named the group of all of these rectangles group right here. I'll say set underscore color, but I don't want all of them to have the same color. In the animation that we want to replicate, all of these have different colors. So I'll say set underscore color by underscore gradient. And this will allow me to set a gradient. A gradient is basically when one color changes from the other or multiple colors blend and change. So the first color is red. I'll say red, comma. By the way, colors in Manim need to be capitalized. Then I have orange. Then I have this sort of yellow, and I think I used yellow. And from these options, I chose yellow C. These are just different shades of the same color. And finally, I have green. So what happened here is essentially we colored this group, and inside of this group, there are 5 of these rectangles from the color red going into orange, going into yellow, and going into green. So the gradient will start from the left and color these rectangles left to right. Let's hit Command or Control S to save and re-render and see what we get. Beautiful, but I noticed that I didn't use the right green color for the very end. This one is a little too blank. So instead of green, I'm going to use pure underscore green, which will give me the purest green color, 02550. It's as green as it gets. So now we've come to this point in the animation. Let's see what happens next. There are 2 rectangles that appear outside of all the squares, and these are called surrounding rectangles. You can create a surrounding rectangle that surrounds an object. So let's come here to the bottom and create the rectangles. Since there are 2, I'm going to name the first one S1, say that it's equal to surrounding, and then I can press tab to autocomplete to surrounding rectangle, and inside of parentheses, I have to say what it surrounds. So in this case, it surrounds 5 of these squares. And remember, we put all of them in a group. So we can say that this rectangle surrounds the group. Now again, this is not going to show up on the screen because we didn't put it inside of self.play. So I'm going to come here, say self.play, right, and S1, which will animate the surrounding rectangle on the screen as well. Let's see how that looks like. Nice. Well, the rectangle is yellow, and in the animation that we want to make, it's white. So I'm going to come here to the surrounding rectangle, add a comma, and see if there are any more parameters for color. And there are. So I'm going to say color equals white. But I also want the second surrounding rectangle surrounding the first rectangle. So I'll say S2 is equal to surrounding rectangle, and this time I want it to surround the first surrounding rectangle, and I also want it to be white. And as well as writing S1 on the screen, I want to add a comma and write S2 on the screen as well. If I put 2 things or 2 animations inside of self.play at the same time, it will play both of them on the screen at the same time. So let's see what we get. Beautiful. Now I also noticed that 2 of these rectangles in the animation don't get drawn evenly. So the second one takes a little bit more time and lags behind the first one. And in our animation, both of them appear at the same time. So how do we change that? Inside of self.play, you can define how long an animation runs with the run time command. So if I add a comma and say run underscore time equals to 3, this animation will run for 3 seconds. By default, it's 1 second. So if I play this, both of the rectangles should be drawn over a period of 3 seconds. See, it's a lot slower. But in this case, I want only the second rectangle to be drawn slower. So I can copy this command and put it inside of this write command. So if it's inside these parentheses, it will only apply to the thing that's being drawn here. And instead of saying 3, I'm going to say something like 1.5. So now the second rectangle should be drawn slower than the first one by 0.5 seconds. Beautiful. Let's look at what's next. Now we have a bunch of numbers that appeared on top of each rectangle. And the numbers are basically text. You can create text with the text command, and inside of parentheses as well as quotation marks, type out your text. So I'm going to say 1, 2, 3, 4, and 5. Now this is just text on its own, so I'm going to assign it to a variable t. You can choose whatever you want here. I just chose the letter t. And this text by default should be in the center of the screen, which means it will cover up the rectangles. So let's place it above this shape. The outer thing here is the second surrounding rectangle. So I'm going to say period next underscore 2, the second surrounding rectangle, and up. So now this text should be next to the second surrounding rectangle, the second line here, and it should be above it. Now if I would play this, nothing would show up on the screen because I didn't put my text inside of the self.play command. So I'm going to say self.play, write, and t to write out my text. And if I play this, there should be text above all of the squares. Beautiful. But in this animation, the text is a little bigger and it seems like every single number aligns with the rectangle. So what we can do is add another period and say scale 1.5, which will make this text bigger by 1.5 times. I could have also increased the font by adding a comma here and saying font underscore size equals to something like 96. But this time I chose to do it with the scale command. So now if I play this, the text should be a little bigger. Nice. Also, what I could have done to have every single number as a separate variable was to create a new one for each number. So I could have said t1 is equal to text and then 1, the same with t2 and so on. This probably would have been a little smarter, but the reason I did it this way was to show you how arrays work in Python. So let's see what happens next. Now each number becomes bigger as each rectangle becomes smaller, and it goes from the first one to the fifth one. Since something is happening on the screen, we're going to use the self.play command once again. And to make this sort of highlight getting bigger effect, we're going to use the indicate command. And inside of parentheses, we want to say what we want to indicate. So for now, let's say t. Let's say that we want to indicate our text. If I play this, let's see what happens. So now all of the numbers jumped up and became yellow. In this animation, they jump up and become red. So we can say indicate t, then add a comma and define a color, and I'll say the color is red. Now if I play this, all the numbers will jump up and they will become red instead of yellow. But the problem now is that these numbers here highlight one by one, and all of our numbers highlight all at the same time. And this is why it was probably better to create each text one by one. That way we could have indicated each one. But there is another way, of course. You see, each symbol inside of the text command act as objects inside of a Python array. So we can call them one by one by adding curly brackets. Each object inside of an array has its own index. The first object is number 0, the second one, number 1, the third one, number 2, and so on. So 0, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 objects here, and spaces count as objects as well. So now I want to indicate the first number, which is object number 0. So I'll say indicate t0 with color red. And now if I play this, only the first number should jump up with color red. Yes. But now at the same time that this is happening, we also want the rectangle to shrink and also become red. So inside of the same self.play command, I'm going to add a comma and define another animation that I want to play. So this time we're going to indicate the first square. I'll say indicate, add parentheses, then I'll say what I want to indicate. This is rectangle number 1, then add a comma, say color equals red, since by default the color is yellow. And now if I play this, both the number and the rectangle should indicate. Yes, but the problem is that this rectangle also jumps up instead of shrinking down. And we can change that here by adding another comma and looking through these parameters to find something that will let us make it smaller. It says here that by default, the scale factor is 1.2, which means the object increases its size by 1.2. So I'll say scale underscore factor is equal to 0.5, which will now shrink it instead of expanding it. And let's see what happens now. So the number expands and the rectangle shrinks. I think it shrinks a little more in this animation compared to our animation, so I'm going to decrease this from 0.5 to 0.3. And now we're done with the first number. But this whole shebang here will be very similar for other numbers, so I can just click Ctrl C and Ctrl V to copy and paste. And all I have to do is change this and this to be the second number and the second rectangle. The rectangle is easy, I'll say R2, and now I want the number 2 to indicate. So this is object number 0, this is 1, and this is 2. So I'll say indicate T2, which should indicate the number 2. I'll copy this once again. Now I want the third rectangle and the number 3. So 0, 1, 2, 3, 4. This is object number 4. Copy once again. This is object number 6 and rectangle number 4. And once again, rectangle number 5 and object number 8. And now if I play this, every single number should indicate. But here it says list index out of range, which means that probably spaces don't count as objects. So I'm taking back everything I said about arrays. So it turns out that for some reason, this is the object number 0. This is object number 1, number 2, number 3, and number 4. So spaces don't count. So instead of saying 0, 2, 4, 6, 8, I'm going to say 0, 1, 2, 3, and 4. And let's see if that works. Yes. So we should get the same animation. Now I noticed that here, when these numbers bloat up, they don't actually overlap with this whole shape. And the gap here is a little bigger. For me, the gap is very small. So I'm going to come here where I said where the numbers should be on the screen. I said next to the second surrounding rectangle and up. And I'm going to add a comma and add a buff value of 0.1. Buff basically means the space between two objects. So in this case, the space between the numbers and the object that they're next to. So this little space over here. And if I play this, the numbers should be a little higher. Just kidding. That means I chose a lesser buff value than the default one. So I'm going to say 0.3 and see how that looks like. Now the numbers are high enough. Okay, let's see what happens next. So everything that's on the screen slowly transforms into a tiny dot, and then this dot expands and fades to black. So first, let's create the dot. I'm going to call it D equals to dot, and inside of parentheses, I'll say color equals red. So we created a red dot. Now we want everything on the screen to transform into this dot. So since we want to see something happening on the screen, we're going to use the self.play command again, and inside of it, we're going to use the same replacement transform command that we used before. So replacement transform, and now we want to say transform from what to what. Again, we don't have all of these objects counting as one object right now. So we need to put them in a group. I'll name this group G3 and say that it's equal to V group, and inside of its parentheses, I have to put everything that is on the screen. So we have all of these rectangles, which are already in a group, so I can just put group here. So now all of them are in this group. Then I have the numbers, which I called T, and then I have two surrounding rectangles, S1 and S2. Now everything currently visible on the screen is inside of this G3 group. And now I can transform from G3 to my dot. Let's see how that looks like. Whoomp. And finally, we want this dot to start expanding, and once it expands and fills the whole screen, we want it to fade to black. So since something is happening on the screen, I'll say self.play, open parentheses, and now I want to increase the size of the dot. So I'll say d.animate.scale, and let's scale it to something like 150 times, since the dot is pretty small. Now again, I wouldn't need to use the animate command if I wanted to scale the dot off screen. So if I wanted to make the dot super big before I showed it on the screen, and I didn't want to animate it getting bigger, I could have just came here, said period scale to something like 30 times, and it would have had the scale 30 immediately. If it's not inside of self.play, we don't have to use the animate command. So now if I play this, everything will transform into a large dot. Whoomp. So let's undo that and make it transform into a little dot. And then let's scale this dot once it already is on the screen. So this is how it looks like now. Next, we want to fade out this dot, and there's an animation for that as well. I'll say self.play, fade out D, which is our dot. So now we should have successfully recreated this animation. And now if I go into details here, I'll see that my output file, or this whole animation, is inside of this directory on my computer. If you're on a Mac, you can just copy this, go to your desktop, click Command-Shift-G, and then paste it in, enter, and it will take you directly to this file. And if you want me to help you learn more Manim and skip the headache of trying to find a bunch of scattered information about it, I've made a full Manim course for beginners. It will give you all the basics like getting to know Visual Studio Code, how to create various objects, shift them together on the screen. You'll find out different ways of animating things, and you'll create a bunch of cool animations that will help you practice Manim skills so that you actually remember them and can apply them yourself to create your own Manim animations. Check it out. I'll leave a link in the description.